Okay, so hello everyone, and I welcome you all for another session of daily Leetcode practice. And we have three questions from easy, medium, and hard. And let's start with the first question. And I'll share my screen first. Let me share my screen. Okay, so you all can see my screen.
Yes.
Okay, so this question is shortest completing word. Here, the in nutshell, I can say what we have to do. So we are providing with one particular string, which is this, for example, and these are the list of words. What we have to do, we need to see what are the characters in in this particular string are present in any of the word, and the one thing is whichever string or word is making that particular string, and whichever that word is the shortest one, that word is an answer. For example, here we have SPST. So we have like the string which we have is SPST, and from the words over here, when we search from a step, we don't have one more S. So it's contain STP, but not one more S. So we need two S over here. So this is not an answer. So when we move to steps, it is an answer for us, which is because it contain all the characters which we need it here, and it is the shortest length. This word is the shortest length from all other length. And when we move to stripe, it is not an answer because S is not there. If that word is a stripes, then also it is not an answer because this is the its length is more than this which we have found. So this is the main question which we need to solve. And one more example is this, where
Sonia, I have a
sorry,
question. I have a question regarding the example one.
yeah.
So, in case of second string STEPS,
Mm-hmm.
what if there is like an additional S there? Let's say STEPSS.
That's not a problem. You need to have all the characters, at least all the characters which are over here. And but the thing is, if there is one more S, then I think this length would be similar like with this length. This is 1, 2, 3, 5, and this is 1, 2, 3, 4, 5, 6. So then yeah, so this is will be steps like with 6 characters, and this is also 6 characters. But the word which comes before, like first word which we see, it would be an answer. For example, over here, so this is
So just to like say, the example that I gave, STEPSS will be the answer, but not the stripe, because stripe contain only one S.
yes.
Okay, makes
Yeah,
sense. Thank you.
yeah. And over here also, we have one single character S. In these words, all are having the single character S, but this is its length is more than this, and so this would be an answer. And although all these three can be an answer, but this comes first, so this is an answer. This is our answer. So anyone has tried this particular question? Any approach? What to think? How we can solve it?
The brute force would be to to sort the word by length, and then just compare one to one from left to right to see, you know, if this if the a word from the you know, if the number of character count is met.
So you are
we sort it, so we guarantee that the first. Oh no, wait. If we sort it, then the the order may be not. May yeah, we may not have the right order in case of example 2.
so you are saying to sort, like you want to sort the word like this or this particular string as well.
No, only the words.
Okay, so but in this, like in a string, we have a like numerics as well.
No, it's sort by length of the word, but never mind, because I look at the second example, that's not gonna work. So the proof force should go, one by one, and keep track of the minimum length so far.
Yeah. Yeah. So anybody else? So one approach which I am thinking is like if I just take only the characters from this particular string and sort it and then traverse one by one to all these strings, and I'll just check and also sort this one by one all the characters, and I just need to check now if that particular string, the substring of this is present in that particular string or not, in that word. So if it is present, then whatever the length, it's an answer.
It may not work if, for example, one string you have 2 s, and the other string, the first string, the license plate, you have only 1 s, and the other one you have 2 s, and when we look for the sub string, we don't find a match, but
why we don't have a match? Because you are saying over here it's just a one string, and over here, for example, there would be a 2s.
Yeah.
That's not a problem. So you at least you need to have one at least character. Whatever the character you need.
Let's say you have, for example, for the first license plate, you have letter A, B, C, right? And then,
Okay.
yeah. And the second one, you will have A, B, B, C. Then if we look for the substring, we cannot find the substring in there.
Okay, so you are saying, yeah, that would be a problem to getting a substring from there. So we can go for a two-pointer approach over here. Whatever the characters we need to match character by character with the string.
Yes.
Like if A would be matching with A, B is matched with B, and if it is like next is also B, we just move ahead, and next if it is C, then we'll match. I think this the matching which we solved the previous one questions before, one of the question which we solved, that approach can be helpful over here also by comparing the character by character with other string.
Yeah, but we don't need to sort them. I think we should do the character count.
We can use a
sorry.
We can use a separate data structure to store the count.
Like a map.
Yeah, maybe a map. Yeah.
Yeah, that's another approach to, like you're saying, like first of all we need to create a map for this. So is there any problem with the last approach?
Which last approach are you talking about? Sorry, I didn't get that.
Sorry?
Which last approach were you talking about?
So which we were solving, like first of all we started with the substring, but substring will not work. Then we started with matching each character by sorting. So in that, is that like we were discussing, it is required to sort or not?
I mean, if you are storing the count, then we need not sort them, right? That's my understanding.
Yes, like sorting is not required here because all we need is count. Okay, given the license plate and the list of words. Okay, any word can be in any, like the characters in a word can be in any order. They doesn't need to be like in the same order. Okay, so sorting is not required. If we can just like calculate a count of characters in the license plate, store them like in a hash
Map.
hash or like maybe array of 26
Yeah,
characters.
that also works.
Okay, and then so we can calculate the length of that array for the license plate, and then for each words. Okay, one way is to calculate that the similar array for each word, and then compare with the license plate array to make sure that all the indexes, let's say number of A in the license plate array should be no, like number of like A's in the words should be great, like in any word should be greater than or equal to number of A's in the license plate. Correct?
Yes.
And then we do the similar comparison for all the 26 characters. And if it holds true for all the 26 characters, that means in any word we are getting all the word letters which are in the license plate with the count greater than or equal to in the license plate, and we are good.
So in this, are you trying like how we'll be searching in this particular count? Like here also we need to create a hash map or take an array for like 26.
Yeah.
For
Can
each.
can you do it like for the example, like first example? Okay.
So yeah. So for example, over here we have S2. Sorry. S2, P1, and
S1, T1.
T1. Yeah.
Okay.
And
now,
our step will be we are having 1. T is 1, E1, and yeah, P1.
Okay, now if you assume like this is like in an array where you are going from like 0 to 25. Okay. So or you can like even use a hash map. Okay, it doesn't matter. See like for the first word S. Okay, okay, first letter in the word S.
It's
the count of S. Yeah, it should be greater than or equal to the count of the previous one.
Yes.
Correct?
Yes.
Similar holds for T, E, and P. Okay. So in this case, the count of S is less than the count of S in license plate. So we cannot like take the word step. Okay.
So like I'm just saying, like if we got to know that we require 2, but it's only has 1, so we'll just break and go to another.
Yes. Yeah, second word. Yes. We don't need to keep comparing. Now Now, if you take the second example where S
Yeah.
is 2,
S is 2.
okay, so this satisfied our constraint.
Yes, and we take the length of it,
No, like
which is,
we just stored this steps like in the array, like maybe in the result.
yeah.
Okay, and then we keep moving forward. If we find a word with a smaller length than the previous results, then we replace it.
Yes. Okay. Yeah, that sounds like an approach to me. Yeah. So anybody have questions on this approach and wants to discuss about it? First of all, and anyone has any problem on this approach? So what's the time complexity of it? It should be like traversing the words would be order of n, and uh, creating a hash map for each word would be an extra step. But
Yeah, so the time complexity, how you will like calculate the time complexity of this problem?
so first of all, order of n for all the words traversing.
Yeah,
Like,
so let's say like if there are n words,
yeah.
okay, and let's say the length of the longest word is m or l. Okay, length of the longest word
Okay.
is m. Okay, so it should be n cross n.
Yeah. So, and creating a hash map also would require, or any like taking an array also require, like counting them would be an um, extra computations to do
Yes,
that.
when we are comparing them, like yeah, it's extra order of 26. Okay, but again, like that's a constant. Okay, so even like if you do that, it should be order of n cross m, where
Yes.
n is the length of the array, and m is the length of longest word.
Longest word, correct.
Then what would be the how would the license plate involved in the time complexity?
For license plate, what do you think?
It would be only the length of that uh, characters, and creating a hash map of it, which would be order of, let's say, L, if there is a length of L is a character.
Yes, so it's constant.
Yeah, it's also constant. So any doubt in this?
So the time complexity would be finally would be m cross m. Yeah. Any different approach? I mean, this kind of seems to me we do kind of like. I mean, is there a better approach than this?
So when we calculate the time complexity, in most of the cases, we don't calculate the time complexity of the longest word. Let's say like the longest word, itself like should be the constant. Okay, so in most of the cases, we calculate the time complexity as order of n, which will be the length of the array. And now the question is, can we do better than order of n? Okay, better than order of n is maybe log n, but anyway, like we have to go through the whole array up to the last to figure out is there a word maybe at the very last index which might meet the requirement and is the shortest word, length word. Okay, so anyway we have to traverse the whole array. So I'm not sure like if we can do better than order of n.
When we traverse the array, you know, for the word that length is smaller than the license plate, we can we don't need to compare it.
Yeah, we don't need to compare it, but anyway, like we have to traverse the whole array. So in this case, like the first step, it is like not matching. So let's say like we ignore it. Then we have to go to the second one, third one. Let's say the second one we found an answer, okay, but let's say there is an word at the very last of the array which is shorter than the second one, assuming, okay. So anyway, like we have to go through the whole array.
Yeah, but like it may not be gain a lot of performance, but we can like move everything, all the word less than the length of license plate to the left, right? Then we know we don't need to search for those words. We can keep track of the index at where we start to search.
Agree. And then how will you move those?
Oh, just swap them.
Yeah, like you will swap them, like
oh yeah.
So for moving to, like, you have to iterate the whole array.
Yeah, but it's only big O of n, right?
Yeah.
But what would you think about, like, I'm thinking of this approach, but I'm not sure if that workable. So let's say I create a map, and let's say this map the key will be a string that would say, let's say here's all the word that have 3 S in it. So the key will be 3 S, and the value would be a list of words that have, that have 3 S. And I create a map like that. Then
yes.
Then I look at the license plate, and then count the character, and then I look up the map to get a list of words, and then I just do the union of them.
Sure, like that approach, like I'm not very sure, like I'm getting it fully, okay, right here. So why not, like, maybe if you want to try it out, okay, try it or post it in the Slack channel, okay, and then we can have like that discussion there, okay, because that way it will be easier for like folks to jump in.
Yeah.
Okay.
Yeah. That's
Okay,
kind of
so,
like the. Sorry, go ahead.
no, it's okay.
No, that guy, I think it do it like inverse document, like Google inverse document. So kind of you search for the keyword, and then you merge them, right? In this case, the keyword will be how many character A, in the license plate, and how many character B will be license plate. And then when we find it, and then we kind of, merge the answer to get a single one. But
Okay. So anybody wants to discuss this, or shall we move further? Okay.
yeah, I think we can move to the next one.
Okay, so